Data flows describe the data movement patterns needed to connect computation with distributed data storage. Even though the virtualization of data flows is an area of active research, it is an essential component of modern collaborative research. When data flows are virtualized, it becomes possible to execute data management services within the network. The Internet 2 architecture team is considering how services can be implemented within the network. Examples of potential services include accessing files by collection and file name instead of IP address, managing access controls through the creation of virtual private networks, caching of files within the network to improve content delivery from locations near the consumers of the data. These services require many of the same capabilities used in traditional data management systems, including naming of data flows and naming of files, management of user authentication and enforcement of access controls to implement a private virtual network, management of data distribution between caches to improve performance. Policy-based data management systems can become part of the network infrastructure, supporting the distribution of applications and data while enforcing collaboration policies. Virtualization requires the ability to characterize the properties of a data flow. The essential properties are selecting the source for the data movement across all replicas of a file, identifying the destination for the data movement, which may be a cache within the network, defining the number of parallel I/O streams to use for the data flow, defining the network paths used to transmit each I/O stream, imposing access controls on the data movement, naming data flows for sharing, supporting execution and re-execution of a data flow. This is important for data streams and the ingestion of data into an archive. If information about these attributes is maintained, then a second researcher can implement the same data flow used by a first researcher. Data flows are easiest to define when they transport data between collections. The source collection may be located in a well-known repository. The destination collection may be a local research environment managed within a data grid. To initiate a data flow, retrieve information from the collection about the locations of a file, retrieve information about the associated storage systems, select the optimal copy or copies to use as the source, identify whether access permissions at each location permit the movement. The data flow needs to apply operations for authenticating the identity of the user, transporting the data to the destination, informing the source and destination collection where the new copy resides, verifying that the data file was not corrupted in transport. At the moment, these steps are performed within the data grid independently of the network. Policy-based networks are now being implemented. The policies are applied in software-defined networks within OpenFlow routers. Policies can be changed to control routing decisions. Integration of data flows and collections is being pursued in the DataNet Federation Consortium. A demonstration was given at Supercomputing 13 on the control of an OpenFlow router by a data grid to define disjoint network paths for transmission of a file over parallel I/O streams. Also, within the Syndicate project, this is integrating caching services with the network to support content delivery systems, and within the Digital Preservation Network, DPN. The DPN project manages a deep archive. An essential component is the controlled staging of data into the archive. This is an opportunity to link the iRODS data grid with the Syndicate caching service to support both staging and retrieval of data. Take 7 minutes to complete exercise 11. Write a paragraph on the data flow properties you believe will be most important. Consider types of data movement. Decide whether data flows are needed primarily for large data sets, terabytes in size using parallel I/O streams, or for very large collections, millions of files and caching of heavily used files. Please load your paragraph into the lifetime library in the subcollection class-INLS 624 by the end of today's class.